Hello guys, welcome back. In this video, we're going to continue our discussion on tidy tools for data wrangling. In particular, we're going to introduce the dplyr package for data manipulation. The dplyr package is a very new package. Like the tidyr package, it was introduced in 2014. The dplyr package is built to work directly with data frames and provides a set of tools for efficiently manipulating datasets in R. As mentioned before, dplyr is the next iteration of the plyr package, but it is faster, has a more consistent API, and should be easier to use. Basically, the dplyr package provides a grammar, in particular, a set of verbs for data manipulation, and uses a consistent syntax to accomplish data manipulation goals. Here is a summary of its key verbs, and all of these verbs are very informative of their intended operations and work similarly. For these single table verbs, meaning functions working with a single table, their first arguments are always a table or a data frame, and the subsequent ones describe what to do using the variable names in that table. And they all return a new table as output. We can also make use of the pipe operator to chain these verbs to form data processing pipelines. Since their uses are very similar to their counterparts in the tidyr package. From now on, I won't go through the parameter list for individual functions unless necessary. Instead, I'm going to introduce these verbs mainly through use cases. In particular, our Billboard music ranking example. Besides, I will not discuss these two table verbs because they are used for joining relational tables. Given that about half a class hasn't taken database courses, I don't want to burden you much. But these two table verbs are very easy to pick up once you've learned relational joins from database courses. Now let's start with creating these two tuples for the Billboard music ranking data, one in the wide format and the other in the long format. We are going to use either one to illustrate the use of a dplyr verb when appropriate without further explanations. Suppose our first task is to select the columns track, week 1 through week 3, and date entered in this specific order from the wide format of the Billboard data. To do so, we can use the select verb to take a sequence of colons in order. Colons are specified by one or more unquoted expressions, each separated with a comma. The syntax we've seen before for colon selections can also be used together. Here, we use this sequence notation to select all colons from week 1 through week 3. We can also use named arguments to rename selected variables, like date entered here, which is renamed to date in the resulting table. Alternatively, we can use a helper function named number range to match colon headers composed by a common prefix and a sequence of numbers. This slide gives you a summary of helper functions that can be used together with the select verb. Actually, the use of these select helpers is not restricted to the select verb, or even not restricted to the dplyr package. They can be used anywhere when we want to form variable selection rules. For example, we can use them with the pivot longer function to specify colons to be pivot into longer format. And most of their uses are straightforward. For instance, if you want to put some colons before the remaining colons, you just list them first, and then use the everything function to include all variables that haven't been specified. And this will save you from a lot of typing. Let's consider another common data manipulation task. Suppose we are going to narrow in on a subset of songs. Say, songs by 10 artists, and see when they rank higher than the average rank of all songs. And we can use the filter verb to accomplish this goal. The filter verb allows us to specify filtering rules to subset observations in a dataset. And it takes a data frame or table as its first argument. And the second and subsequent arguments are the expressions that filter the data frame. These logical predicates are defined in terms of the variables in that data frame, like artist and position in these two conditions. And as vector recycling make it easy to select values that are higher or lower than a summary statistics, like the average ranking position here. And these two conditions are connected with the logical AND operator. So only observations for whom this whole thing evaluates to true are kept in the output. And many tools in both base R and dplyr can be used with the filter verb to compose sophisticated logical predicates for filtering. And they are summarized here. If we want to sort weekly ranks, we can use the verb arrange. Arrange takes a data frame and a set of colon names to order by. Later colons are used to break ties resulting from earlier colons. And for descending order, just use this function around the corresponding colon names. So in this example, I first sort observations by artist in ascending order, and then use rank and position to break ties. First sort ties by rank in descending order, and then sort ties by position in descending order as well. Next, suppose for each song, we are going to calculate its weekly changes in ranking position and create new variables accordingly. To achieve this goal, we need the verb mutate. Mutate takes keyword value pairs of expressions to specify the required transformations and the names of the resulting colons. We can also use mutate to remove variables and modify existing variables. For example, here we create a new colon named current by simply duplicating the position colon, and use an offset function to find the positions ahead of the current ones and create a colon named previous to store them. In the same mutate function call, we can create later colons by transforming colons that we just created. So here, I create a colon named change to store the difference between values of these two former colons. And it would be better to store weak numbers as integers for later analysis. So here, I use this string processing function to extract the digit part from original character values and convert them into integers. Then resize these resulting integers to this V colon. And lastly, I remove the old position colon by setting the name to now, so as to avoid data redundancy in the output. Here is several examples of operations and functions that could be useful for creating new variables. Among them, there are an important type of functions called window functions. A window function takes n inputs and returns the same number of outputs. Window functions provided by the dplyr package include a set of ranking and ordering functions, two offset functions that allow us to compute differences and trends, and a set of functions that compute cumulative aggregates. The output of a window function depends on all its input values, and we'll see more on their applications with other dplyr verbs soon. The mutate verb keeps all existing variables. But if all we want to keep from data transformations are those newly formed variables, we can use transmute as a syntactic shortcut. Now, no setting position to now and alike are needed anymore. Let's consider another common type of data manipulation problems. Let's say we are going to group weekly ranking positions first by week and then by artist. We can use the group by verb to take a set of grouping variables. When multiple grouping variables are present, group by groups observations first by the first variable, then by the second variable, and so on. And the result shows the number of groups generated by this grouping along the original data. We can access the grouping information by using the groups and group variables functions. If we call group by multiple times, by default, the latter grouping will overwrite the former ones, as shown here. Only the grouping defined by the latest call to group by is kept. But group by in fact allows us to append new grouping rules in a subsequent call by setting this AND option to true. And the dplyr also provides an ungroup function to remove existing grouping. As shown in this example, once ungroup is called, the grouping information then gets lost. With group data, we can use the summarize function to compute multiple summary statistics all at once. Again, the summarize function takes keyword value pairs of expressions to specify the required aggregations and the names of the resulting columns. Here, we use these string literals with spaces to create more descriptive names. And these names will be enclosed by backticks in the output. So this pipeline shows how we can implement the split apply combined data analysis paradigm with dplyr verbs. One interesting thing about the summarize function is that each call to summarize removes a layer of grouping, as shown here. Since this summarization is performed for each artist, the grouping defined by artist gets removed from the result, while the first layer of grouping is still effective. Here is a summary of aggregation functions we can use with the summarize function. In addition to functions such as min, max, median, etc. from base R, we can also use the following functions enabled by dplyr. For example, this n function returns the number of observations in the current group. N distinct gives the number of unique values in a variable specified by this argument. First, last, and nth. They work similarly to their indexing equivalents, but give us better control over the result. In addition to group-wise aggregates, all dplyr verbs discussed so far can combine natural with group by to enable by-group operations such as group-wise sorting, filtering, and transformation. For example, we can use arrange on grouped data to sort within group observations. But to do so, we need to turn on its by-group option. Otherwise, grouped arrange is the same as ungrouped ones. Here, we use the mutate together with this window function on group data to figure out the highest rank a song reaches so far as time goes by. So each call to this window function takes all ranks for a song and outputs the cumulative minimal. And here, I narrow in on two not very successful songs to help you see the effect of these group-wise transformations. As you can see, the highest position for these two songs did not influence each other. Next, I show how we can use the group-wise filtering to find all weeks of rises for each song in this dataset. Again, I narrow in on these two songs to help you see the effect clearly. In the end, I would like to talk a bit about how we can save and reuse our data processing pipelines. Essentially, a pipeline describes a function chain. We can use the placeholder to specify what input this function chain expects and give it a name. After that, we can use this name to refer to this function chain whenever it is needed in a pipeline. All right, this is all for data wrangling. Next time, we are going to start a new unit on data visualization.